Welcome all to the next section of physics class. First of all, we have learned about charge and also the current. Related to these two concepts, another one more term we will be using. When we are this voltage, we will call it as electric potential. What do you mean by electric potential means? I will give an example for it. Here when we are taking two containers and one is having the water level, this is the water level for that, and this is the water level for this is A, this is B. So when we are considering the water level of two containers, and first one is having more and second is having less. So when I am trying to connect these two, these two, what happens is the water will flow from A to B, right? Same like that, how we are considering the water level which determines the water flow, same like that the current flow is determined by a quantity, or a term that is called as electric potential. So electric potential which determines the flow of current. We are trying to express in a physical quantity, we need to measure it. How will you measure it? Electric potential. We will be considering the electric potential related to the work done. So now we know that the charge is responsible for the current. And we know that the charge is moving from one point to another point. And here you need to know that the work done in bringing a charge from one point to another, or here basically the electric potential means we can represent it by the letter V, and that is equal to work done in bringing a unit positive charge from, we can say that from a far point, that is infinity to a point, that is called as electric potential. So we can say that, what do you mean by electric potential? Work done in bringing a unit positive charge from infinity to a particular point, we call it as electric potential. We are going to measure it, right? So we need a S unit. The SI unit of potential is volt. How we can define 1 volt? That is, I am just writing the equation for it, that is 1 volt is equal to, what is the unit of work? That is joule. And what is the unit of charge? That is 1 coulomb. That means if 1 joule of work is done in order to bring 1 coulomb of charge, then we can say that 1 volt potential. So now this is what the SI unit and also the definition for the unit. Now we will see, getting into the another one more thing, that is potential difference. It is same related to the electric potential itself, but we already know the potential of a point A and we know the potential of point B. They are having the potential different, or we can say that we already know the potential of A and potential B, and we are bringing a charge from one point to another point, and how much work we have done, that is called as potential difference, and that is V is equal to work done upon charge itself. But we will be considering it as what? VAB, that is the potential, VB minus VA, that is the potential difference, work upon charge. So this is what the potential difference, that is potential difference, we say it as work done in bringing a unit positive charge from one point to another. And also its SI unit is same as how we have learned. The SI unit is volt. Now we are clear with the charge, current and also potential. So when we are relating it, a person named Ohm have found some relation between I and V. I and V means what? I is the current and V is the potential. So when we are dealing with these both, he has stated that under constant temperature and pressure, that means when the physical conditions are constant, we have observed that when a current is flowing through a conductor, we see that there is a change in the potential and it is directly proportional to it. That is, I is directly proportional to V. A person named Ohm have found a relation between the current and the potential, that is current and the potential. And relation exists when there is a physical condition physical condition remains same. And this law we call it as Ohm's law. So I is proportional to V. What it says is, when a current is flowing through a conductor, then we can see that the potential also directly increasing, or it is directly proportional to the current flow. Potential is directly proportional to the current flow. So that is what under the physical condition remains constant. Equation as V is proportional to I and V is equal to, in order to remove the proportionality sign, we will multiply by a constant R. So that is, that constant we call it as resistance. And here that is V is equal to IR, and now we are getting the value for the resistance V. R is equal to V upon I. So here what do you mean by resistance? Normally, as we have known the meaning of that word resistance, that is what? It is equal to the obstruction. The resistance means the obstruction to the current flow from a conductor, that is commonly called as. So here we are getting the equation for the resistance from this Ohm's law, that is R is equal to V upon I, and what is the Ohm's law says? That is V is equal to IR. So here if a conductor is following this rule under the constant temperature and pressure, we can say that they are called as ohmic resistors, and if they are not, then they are called as non-ohmic resistors. We are clear with the what do you mean by charge, then current and potential, how they are related with each other using the Ohm's law, and from that Ohm's law we have derived the equation for resistance, that is V is equal to IR, and also from that we have got an equation for resistance, that is R is equal to V upon I. And the resistors which follows this rule under the constant temperature and pressure, they are called as ohmic resistors, and if they are not obeying this rule, they are called as non-ohmic resistance. So now I am sure that you are all clear with this basic concept of this chapter. Thank you.